Okay, so today is our second supplemental lecture to prepare you for SRR and SDR. The topic today is risk management and FMEAs, which if you recall means failure modes and effects analyses. Before I get into that, however, I want to give you a little bit of a roadmap for what's coming. So I've kind of finalized all the remaining content that I will be delivering to you. And I should have all of this to you by Monday, if not sooner. And it's as follows. We did the first recording about the clarification on the intro, the functions and requirements. This one's on risk identification and management and FMEAs, which is content for your SDR portion. My third one, my video will be on the topics listed here. Some of them related to SRR, some of them to SDR. It's kind of cleanup to make sure I'm clear on all the topics that are listed on this slide. I may combine that recording with the one that says 3B or number 4 on system budgets and intro to DFX and cost estimation and control. The reason why I'm doing it in the order I am. It has to do with kind of the quantity of work required. So I'm trying to do the videos that will be the hardest to achieve first, working down to the easiest to achieve as we get closer and closer to red teams. So hope that's helpful. But this is your roadmap. We are having class on Monday, December 1st, and these are the topics I'll be covering there. And of course, I'll be available to answer additional questions. And then red teams kick off on Wednesday the 3rd. So get excited. All right, so on to our topic for today, risk and opportunity management. First of all, what is risk and opportunity management? As it says here, it's a structured approach to identifying and actively addressing potential risks and opportunities during system development. Okay, this is all kinds of risks: technical, safety, cost, schedule, regulatory, political, you name it. Anything that could put either the technical solution or the program as a whole at risk. Now, in this particular presentation, I won't be talking a lot about opportunity management, but just know that there's an upside and a downside, right? Risk is addressing downsides. Opportunity, which should be done more than perhaps it is on a lot of programs, is the upside opportunities. It's the where could we find additional savings? Where could we get additional performance? Like, let's really explore that space. And so that is done, hit or miss is my experience based on the programs. So that's just an FYI that we're going to focus on risk because that's what I want to see in the presentations this month, but maybe at some other point in time you could explore the opportunity management piece as well. So to define terms, all under the umbrella of risk management, first of all, you have a risk register, which is your list of risks with some pertinent information. Your risk matrix is how you then project or visualize the set of risks on one graphic, and I'll go into that. And then risk burn down planning and management is how you then look at addressing those risks which you could potentially do something about in order to make them less risky over the course of the program. And I'll go into that as well. Required for the SDR, and again, the last chart and the last part of this video will be describing each of these in more detail after I've talked about them, but you'll be asked to create a risk register for your system. You'll be asked to create a risk matrix, of the 5x5 matrix, and risk burn down plan. There's a correction to this chart that I needed to make, which is that I'm asking you to do 2 burn down plans later. So I'll correct it on the chart when I put it on Brightspace. Sorry about that. And then here's a couple of links to some references. They're really long and really detailed, so I don't know how helpful they'll be to you for the immediate, but for long-term reference, I think it'll be great to have those references. Okay, so let's now get into the meat of it. So let's talk about a risk register first. The risk register is the list of all the program risks. The information on each risk that is necessary at a minimum are the category, a unique ID number, and again, just like putting page numbers on all of your slides, you need to really pay attention to your ID numbering for your requirements and your functions and your risks so you don't get it all mixed together, okay? So unique ID number for your risk, a short description of what the risk actually is. This is so that we can all be convinced that you know what you're talking about and that you know what it is that's actually risky about the thing you're bringing up. And then there's something called likelihood of occurrence, severity of consequence, and then there's an overall level that I'll explain here in a few minutes that comes from this 5x5 matrix. So that will be described here in a second. And then a response category. So those are the kind of the minimum standard. You can have more information about risks as well, but that's kind of the minimum. With regard to those categories, I've included a list of the 5 categories here that are most typical. There are additional categories that could be used, but these are kind of most typical. And there's 5 risk responses that are also most typical: avoid, mitigate, transfer, accept, and monitor. So the descriptions of the purpose and when you use them are all included here. So I'm not going to go into a lot of detail there. So I do want to say, however, that on the risk register category, at least 2 risks in each of the 5 categories will be required, and with a minimum of the information that's shown on the columns of this table on this slide. So a risk for all the risks on the risk register: what's the category, what's the unique ID, what's the description, likelihood, consequence, overall level, and response. So that's an example. It's kind of a silly example, but hey, why not? So that's the risk register. Now let's talk about the risk matrix. So often when you see information about risks, this is what pops. Like this 5x5 matrix that includes 3 colors on it, red, yellow, and green, is the quintessential representation of programmatic risks, system risks, even company risks. This has taken hold everywhere and is the kind of a model for a good structured approach to addressing and tracking risks. So let me just explain what you're looking at here. So on the x-axis is severity of consequences. In other words, if this risk happens, like if you realize the risk, it's called risk realization, how bad is it really? Is it not that bad? That's the very low. Is it catastrophic to the mission? That's the 5, okay? And then there's levels in between. So that's severity of consequence. Likelihood that it's going to happen is on the y-axis. So very unlikely is a 1, almost certain that it'll happen, if not certain, is a 5, okay? So when you look at those 2 things together, severity of consequence versus likelihood, you're gonna map each of your risks to one or the other. If you recall in the last slide, there was in your risk register, you're gonna have a column for severity of consequence, a column for likelihood, and then a total score with a color. That total score with the color is what maps to this specific risk matrix, okay? And what I've done is I've taken the opportunity to put the unique ID on the matrix as is represented on the risk register. Again, you'll notice that very quickly the audience can absorb exactly what it is that kind of the risk posture of the overall program as you see how many fit in the reds, how many fit in the yellows, how many fit in the greens. The scoring is a notional scoring. Some programs, and you are welcome to do this as well, will just do a multiplier. 4 times 4 is 16, so where it says 22 right now would be a score of 16. 5x5 is 25, and on down. This scoring is used often by NASA as a way to provide further differentiation between each of the red squares and yellow squares and green squares in order to better understand what's actually worse than something else. So you have the option of multiplying those numbers however you want, but that's the region that should be red. It should be the upper right corner in that pattern. That's the region that should be yellow on yours, and that's the region that should be green on yours, just so you know. Okay, so as I mentioned, this is the industry view into risk for all programs, and literally what will happen is the program manager or the risk manager or the systems engineer will get up and will show this matrix, and often within slideshow mode, they will move the mouse and will literally click on one of them, and if there's a question about one of them, and it'll take them to a backup chart, a backup slide that has much more information about that specific risk. And then they'll explain it and describe risk burn down plan, which I'll get to in a second. And then there'll be a return to the matrix place to click on that chart that will take them right back to this exact screen. And they'll go back and forth until everybody's happy and they're ready to move on with the presentation to whatever's next. So that's a strategy you could use as well if you wish. It's up to you. So note that I already went through the general definitions of likelihood and severity, but I have several examples, and there are a lot of examples out there, given how extensively this is used, about more specificity with regard to the 1 through 5 in each of those in the columns and rows. What I'm requiring for every team's SDR is that you have a matrix with 10 or more risks on it, and I want to see at least 3 red risks. I don't have 3 here, but I want you to have at least 3 red risks up here. Force it if you need to. If you think deeply about all the risky things across all those 5 categories, it should not be hard to come up with a lot of red risks. And I want to see at least 1 red in each of these categories. 1 safety red, 1 technical red, and 1 cost or schedule red. Those are programmatic things. I'm not limiting you to just 1 in those categories. I'm not limiting you to just 3 reds overall or 10 total. I just want to see at least that. And I think this is an example statement that if you think about the concept of a bluff, bottom line up front, some statement about our highest risk as a program is this risk, and it is rated this rating, but we plan to mitigate it by doing this and reduce it to level this by this point in time. This is a statement that is a good way to kind of summarize your clear understanding of your team's highest risk, because that is what the first thing that companies and program managers and leaders and customers will hone in on is what is your absolute highest risk. And so having a very clear, showing you understand what it is, showing you understand what to do about it is a really good idea. So, and I'm going to talk about what to do about it on the next slide, but after I show a few more examples of this risk matrix and how they define different things. So here's from the Gozar reference that I mentioned, their program ranking definitions, and how they talk about technical cost, schedule, and safety risks and the consequence categories, as well as their probabilistic model that they do for likelihood and what that all means. Okay, I'll let you peruse that on your own. In addition, they provide this, and this is an example of their risk register on the right, and then the top program risks that are all summarized on the left. I want you to notice a good practice is, as you get in the habit of reviewing your program with whoever the program review authority is, which is often at least on a monthly basis, depending on the size and speed of the program, it's a good practice to put in trend lines. Like, since last time we talked, in this case, if you look here on the left side, the number 1 risk has actually become more risky. And why is that? Well, you should be able to explain that. The number 3 risk has also become more risky, not less risky. Again, explain that, or it's unchanged if it's flat. So you can see that both on the left side in the trend line, as well as the trend line in the program risk summary on the right side. So that's because you will only be briefing your risks once. That's not necessary, but just wanted to let you all know that that's a good practice in the real world. Okay, here's the NASA Manned Spaceflight Risk Scorecard. You'll notice the numbers are the same. You'll notice they also mention a time frame. The time to initiate what they call the handling strategy would be the risk handling strategy or risk mitigation strategy. Those terms are sometimes used interchangeably, risk mitigation or risk handling. And you'll see there's a slightly different breakout of categories and some different words that are used on the likelihood and consequence scales. All right. This is another one. I forget what this is for, but I thought it was interesting because, again, it has some different take on categories and subcategories and some different definitions for each. So again, these are just kind of for reference. You could look up some of these things yourself and find a lot of interesting information out there that you may wish to use in this presentation or just for future reference. Okay. This is the last category on the risk management piece, and this is the risk burn down plan. So if you choose on that your risk register that you say you're going to mitigate it, that's what this means, is you're basically wanting to reduce the risk. This is a tool. So with good planning, you should identify early what your big risks are on a project, and you should have plans to address them early on to make them less risky later on. And that's what good industry programs will do. And this is the main tool they use, at least to record what they did or to make the plan for how they're going to do it. And why is that important? Well, you have to build that into your planning for your project. So you have to have workers that actually do these things. You have to have money to do these things. You have to have a good justification for why you're going to do these things, because it's going to increase the cost, it's going to potentially increase the schedule, but it's probably going to be worth it, especially for your high risk items, especially those things in the red. So what I've done is I've taken a shot at wait a second, let me finish explaining the main parts of the chart here. These tasks, the individual tasks in a risk burn down plan, are called risk reduction activities. That's kind of a generic industry term. So if you're going to talk about these things in your presentations, saying our risk reduction activities is something that would be instantly recognized by industry members as a common terminology to describe this. And it could be anything from technology development, analyses, regulatory changes, you name it. You'll even see in some of these task descriptions that some of them are, as the program matures, you're going to hold less margin back for weight or for communications link or things like that. You start releasing those margins and making them smaller as you get closer to deployment of the system, which automatically will mean you've got more room and potentially have moved from red to yellow or from yellow to green just because of that. So the minimum set of columns for your risk burn down plan are the ones that I have listed in this example. And so I'll talk through it now, and then we'll talk about what that might look like for you. So you'll see here there's tasks, and they're numbered tasks for this specific risk. And again, I chose from the last video, I talked about the requirements decomposition for the timeliness requirement of 30 minutes refresh of the data. Now, let's say we were a little exceeding in our initial estimates the 30-minute requirement, and we're at 32. And really, you should have 30 plus margin. So ideally, you'd be down at least 10% margin in the 27-minute time frame in your budget. But let's just say we're at 32 to start, okay? And we're here at SDR, and we know this. So you might have a plan that would include something like, okay, we see a good opportunity to reduce some of that time by upgrading our processing software to reduce planning and data formatting time. Awesome. There's going to be a cost associated with that activity, that risk reduction activity. There's going to be when you think you can achieve that, when you're going to get it done. And then there's what's the impact going to be both in the measurement of that thing, In this case, it's minutes reduced for total time to turn around a new set of data to the models. And what's your new risk score? What did it go from and to? I don't like all the ways I've referenced schedule and metric impact and risk score here. I'm sure you could come up with some better ways to represent those things that are clearer, but just know that this kind of information is what's expected in a risk burn down plan. What are you going to do? What's it going to cost? When are you going to get it done? How long is it going to take? How good is it going to be at improving both the measurable performance of the system as well as reducing the measurable risk from the 5x5 matrix? Those are the fundamentals, okay? So for your SDR, I want every team to do a burn down plan like this that shows the reduction, that shows when that happens roughly in the timeline of a program for at least 2 of your red risks. And that would be not 2 from the same category, but 2 from 2 different categories. If you recall, I'm asking you to have at least 3 red risks total across 3 different categories. And so pick 2 of those from 2 different categories to do a burn down plan for. Have fun with that. I think this stuff is interesting. As you think deeply about what are those things you could actually do to deal with potential issues that might happen on your program as you develop it further into PDR, CDR, and build. Okay, so that is risk. Now, not too much more here. I'm not going to spend a lot of time on this because I want to give you some creative license. I feel like I've kind of squashed a lot of the creative license out in this phase, especially compared to the scissor phase. Just know that I'm not going to be super picky about this, but I am going to provide some direction here. So FMEAs, failure modes and effects analyses. They were invented in the 60s for the aerospace industry, and now tons of industries use it as a way to think differently about risks that they have. This could be fund management in the financial industries. This can be, utilities industries, you name it. These are kinds of things that are very helpful tools to use. So here are the essential steps. You identify the failure mode. In what ways, so this is like thinking about functions, right? In what ways can the system fail? Okay, so the solar array doesn't deploy. That's bad. Obviously, but that's a failure mode, right? I'm not going to come up with more examples. So there are some examples down here. How can the system fail? What happens if it fails? Why would it fail? What are the possible causes? And as you think through those failure modes and what the effects might be, you should have a little bit of a sense of 2 of the same things as the risk management section, the likelihood and severity, but also the detectability. Like, how do we actually know? Like, is it detectable or easily detectable or not? And then there's a way to compute it through the FMEA analysis. It's a multiplier. And then again, a mitigation plan. What would you do? Now, in this case, the mitigation plan, I don't expect you to do like a burn down plan, just in general, what could we do now to mitigate that potentiality later, okay? The risks are the severity, the likelihood, and the detectability have a 1 through 5 metric here. There are ones you can find online that have 1 through 10 and that have more fidelity than between those. Feel free to use those if you want. Here's a spacecraft example potential. Okay, the battery overheats. That's a failure mode. You have power loss and there's severity and likelihood. Or the reaction wheel, the bearing seizes, or the antenna has a stow failure. Okay, so you wouldn't know straight away what are the most likely kind of failures you might have on your aircraft or your spacecraft. But sometimes and often there are reports about, regular failures of a certain component, or especially when there's a failure of a satellite or an aircraft, there's going to be a determination of what is at the root cause of that. And then every other aircraft or spacecraft that has that component, you're on high alert because of that. And if you're designing that component into your system, like you're in the design process, you might want to think long and hard about whether you want to switch that out at the last minute. Or if there's a way to design, or if there's a way to mitigate that while still having that component in your system, but just with just high levels of awareness of what could happen. So that's failure modes and effects analyses in a nutshell. For your SDRs, like I said, there's a lot of information available about FMEAs. I want you to have creative license. I want each team to create at least one FMEA for a risky or technically challenging part of their system design, and I want you to brief that at your SDR, okay? This is just a possible structure. At least it has the most core elements or the most essential elements of a FMEA in terms of like the information. You don't have to name it in this way, although the severity, likelihood, detectability, and then the computation you should definitely have. You should have something that says, what is it that's failing? What is the mode? What's the effect? What's the cause? And then what am I going to do to mitigate it? Okay. You can have more than that. You can change some of the names a little bit. It's whatever tells your story the best. And again, there's a lot of information out there that can help you with that. So have fun with that. I think that'll be really interesting. So to wrap up this section, risk management and FMEA for the SDR. So I pulled out all the things I said I want you to do, and they're all here. Each team should have a risk register with at least 10 risks. I think 10 would be that would be a pretty small number, honestly. Think deep about all the possible risks and have at least 2 from each of the risk categories that I've listed here on this table. Then you should have a 5x5 risk matrix with at least 10 risks on it. I would recommend having all your highest risks and maybe all your risks, unless you have an inordinate number of them, okay? So get your risk matrix up there. At least 3 of those 10, or at least 3 of those, however many you put up there, should be red, with at least 1 in each of the 3 categories I mentioned: 1 safety, at least 1 technical, and at least 1 cost or schedule risk, red risk. Then you should choose 2 of those for a risk burn down plan, 2 red risks from 2 of the categories. And finally, create at least 1 FMEA for a risky or technically challenging part of your system design. Okay, so that is the summary of this section and the things that are going to be required for SDR. If you have any questions, as usual, reach out to me and let me know. All right, enjoy.